Okay. So to the minutes. So there doesn't seem to be any announcements for today. We'll start with workloads discussion topics just to let anybody who is here solely for that purpose participate and move on if they'd like to. So there are two caps that are currently open: staple set volume resize and maximum available for staple set. Neither of these are actually merged. And I think probably they should be, even though some of them have, particularly the volume resize has some outstanding items. We've agreed to discuss it at a minimum, so it seems like we should merge it at this point and continue resolving that until we get into an implementable phase. There's even some criteria there. There's some things I would like to see added to it, but if nobody has any objections, I'm going to try to move forward with pushing that to be merged as accepted. Or, yeah, I think accepted is the state where we're continuing discussing. And Mike's proposal for maximum available and staple sets. Again, it still has some open issues, and I'm not quite sure we're at a place where it's ready to be implemented yet, but I think it's ready to be accepted at this point. Like, we should merge it and then work out the rest of the issues from there, in my opinion, just because it seems like there's enough momentum that people are interested in it. We're definitely interested in discussing it, as evidenced by the number of comments on it. And it does seem like a valuable feature. There, faster updates for staple sets is something that people generally wanted. Something we've been hesitant to do because we don't want to break the semantics, but it was also something prior to V1 that we said we would consider doing later on. So I'd like to move forward with that if people don't have any objections. There are some test failures, but they mostly look to be assigned at this point, so there's nothing super critical there. If people want to go and look at SIG Apps issues, if they'd like to contribute to any of the test failures / bugs, contributions are always welcome. Anything else? There's been some discussion about volume provisioning for daemon sets now that we have local PVCs, and we have this new way for daemon sets to use local storage other than host path. That hasn't evolved into a cap as of yet. I think SIG storage is kind of like thinking about it. If that evolves into a cap, we'll present it here. And there's other talk in SIG storage about volume snapshotting and the interaction with applications. So in talking to some of their members, I was considering discussing with this SIG supporting kind of a joint effort to make sure that application quiescing and unquiescing is well supported inside of the storage snapshot. This would be out of tree work. Snapshots were proposed to be done in tree, but SIG architecture thought that generally speaking, it could be done out of tree, and so should be. So that's the path they're taking. They're asking for app input on how this should interact with controllers, how it interacts with pods and workloads. So there may be some effort to be done there jointly with SIG storage. And other news for joint work, we have the sidecar cap still open, and I haven't been able to find work progressing on that. I want to go chase that down. I think sidecars are valuable, particularly for service mesh type technologies where you're doing automated sidecar injection via mutating webhooks, controlling the lifecycle and being able to support applications that are just developed with Docker and are going to have a sidecar injected underneath them unbeknownst to the application seems like something we need to do. And that was all I had. Does anyone else have anything they'd like to discuss for the Workloads APIs?
Can I just interject about the sidecars?
Mm-hmm.
Yeah, so there's been a little bit of work going on the sidecar front. We've got a working proof of concept at the moment, which you can have a look at. It's in a branch. Just uploaded a short little video as well today, just to help show what the behavior.
Okay, I couldn't find a PR that was issued though.
Yeah, there's if you look on the actual sidecars issue in Kubernetes enhancements, most of it's being put in there. I'll link it into the chat.
Cool.
I do have one question about something unrelated. How's the cron job kept coming?
Still no progress as far as I know. So Janet hasn't had the time to actually go ahead and write it. I haven't had the time to write it. The proposed author who said she would take care of it, I've not seen that output yet. Failing that, someone else would have to step up and do it. I could probably take a stab at it. I've been trying to communicate with them, and he continued. It's been like I'll get it to you by Monday. I'll get it to you by Monday, and I haven't seen the PR yet. Benefit of the doubt, maybe the PR, he's working in a branch, and the PR will get issued soon. But failing that, I think we'll have to move forward, and someone else is going to have to take over. The other thing we're also kind of looking at is we need to do something with PDB in the same vein. That should go GA soon as well. I think that one might be even easier just because I don't think we're going to change the API when we promote it to GA. But we should have a plan for that at least.
All right, thank you.
Okay. If there's nothing else, then we've got a demo from Crossplane, which is really kind of a cool concept. Matt and some others had offered a kept in SIG Apps about trying to come up with some open community primitives that represent resources on private or public clouds, like databases, so forth and so on. This would be kind of like the evolution of service catalog, but instead of having these like PDC style service brokers, you would just have resources that are Kubernetes style CRDs that would represent databases and or other cloud common primitives. And you could have controllers that would provision resources on your cloud that would be external to the cluster, or you could have controllers that would provision the same resources in cluster if that's what you wanted to do. And there's a company, Crossplane, who actually has built, I believe, a business around this idea. And if they're here, it would be cool to see a demo.
Yeah, hey there. This is Jared. I am one of the maintainers of the Crossplane project. So thank you for having us this morning. Matt had reached out a couple of weeks ago, so we got some time on the calendar today to come visit you guys. So thank you very much for having us. So let me go ahead and try to share my screen and see if I can convince Zoom to let me do that. So do you see some slides here on my screen now?
I do, Jared.
Excellent.
Yeah, we all see.
Alrighty, cool. So let's go ahead and jump into what this Crossplane project is, and this is a pretty quick set of slides here, and then we'll poke on some things on the running system. So we can make this interactive if you have a question, but it goes pretty quickly, so it might be best to hold questions to the end, but we'll see. All right, so let's first talk about what Crossplane is. We already got a good introduction there that kind of captured the essence of it. So really, the core fundamental of what Crossplane is accomplishing here is that it's a multi-cloud control plane. So it's an API, a set of controllers, et cetera, that spans across cloud providers, regions, on premises, a lot of different disparate environments. It's based on the Kubernetes engine, so it surfaces the declarative API for users or administrators or developers to interact with. And the key thing that it's going after here is to accomplish portability of your workloads across all those different environments, cloud providers and on-premises. And we see those workloads as being heterogeneous, where they're not just containers. They could be other types of resources as well. Databases, message queues, serverless things, maybe VMs. That they're more than just container workloads. And so it's comprised of a set of controllers that will manage the lifecycle of all these different resources that your workloads need, and a scheduler as well to make some smart decisions about where to place those resources for and optimize for a number of different features that we'll get into. And the model here is also a separation of concerns between the developers that want to deploy their workload or their application and administrators that are operating the various environments that are being used in. So it's an open source project. It's community driven, extensible, Apache 2.0 license, and the community is growing there. So we are very, very happy to have people come on in. I don't think that I need to tell SIG Apps folks too much about why multi-cloud would be is an interesting thing. But for me, just the real key part there is that it grants you that power of choice. You can make, when your application can run in a portable way in many different environments, you get to make good decisions about what features or facets or attributes you want to optimize on. Do you want the cheapest? Do you want the geographical region or governmental compliance, et cetera? So that's the reason why I think multi-cloud is an interesting thing to pursue. As we talked about crossplane, the multi-cloud control plane that crossplane is, it's based on the Kubernetes engine. So the Kubernetes API server and etcd to persist things, set of controllers, custom resources, et cetera. So what that does, this declarative API based on the Kubernetes engine, what that enables is, integration with this, all the rich set of tools in the Kubernetes ecosystem. kubectl, it's so with custom resources, it slides right on in there for a first-class experience, and other tools like Compose or whatever you want to use, to interact with this declarative API. Same tools that you're used to in the Kubernetes ecosystem would work. And so we think that Kubernetes did an amazing job at learning a lot of lessons from what it takes to orchestrate containers, and we think that those lessons apply to portable workloads and other resources as well. So as we talked about before, there's a set of custom resources that in the control plane in that that will be available for you to use. Now these model cloud provider resources like RDS, Amazon RDS database, or a Google Cloud SQL or Google GKE cluster. All these managed services and infrastructure that you find in the cloud providers, we have CRDs to match those as well. And then, a set of custom controllers that will be sitting in reconciliation loops, looking for changes to the CRDs or any deviation away from the user's desired state with the actual state, and then take those reconciliation steps to drive the actual state in line with the desired state. So let's take a quick look, I think, at the architecture here real quick. So in the middle there is what we could say is cross-plane. That control plane is comprised of the API machinery, so the API server and etcd for persistence, and then we've got that set of controllers and a scheduler as well that are all running in reconciliation loops. And so on the left side of this diagram, we have all the various tools in the ecosystem that we're talking about that can be used to interact with Crossplane because it exposes the familiar declarative API that other Kubernetes resources are exposed with. And, you kubectl or, client Go, whatever you want to use to interact with it. And then on the right side of this diagram, we have, the set of cloud providers and all of their managed services that you'd be able to interact with or provision or manage, configure, control the lifecycle of them basically. And then in addition to the big public cloud providers, there's also, a set of interesting independent cloud offerings, Cockroach and Mongo or Redis Labs, et cetera. Those are all interesting as well, and, can be provisioned and managed their life cycles as well using this control plane that spans across cloud providers, independent cloud offerings, on-premises, et cetera. So here's where I think it gets real interesting, is this whole concept of portability that we've been talking about. Workload portability is a big goal of this project. And so the way that Crossplane is doing this is in a very familiar way that you're probably already used to for what's done with volumes. So with volumes, you can have a persistent volume claim and a storage class, and that enables the ability for a particular storage request to be fulfilled in a general way. As a end user that wants to deploy an application that uses storage, you don't need to know if it is a Google persistent disk or if it's an Amazon EBS or a Ceph volume from Rook. You're just expressing that your pod needs some storage to consume, and this volume abstraction handles that for you and provides that storage to your pod. So in a very similar way, what we have here for workloads is all sorts of other types of resources, or can now be brought into this environment and managed in a similar way, such that your application doesn't need to know what environment it's going to run in. It could be in Amazon's cloud, or it could be in Microsoft Azure, or it could be on premises. You write your application once, and it should run anywhere in a portable way. So a little bit more details about that separation of concerns, that I was getting into there. Like similar to a PVC, persistent volume claim, and a storage class, we have this concept of resource classes and resource claims. And we'll see that in the demo here in just a second. But basically what that enables is that as a developer, you just have to define your workload in a general way and not know any specifics. And then an administrator for your environment that knows all the different cloud environments that are available to your organization, and they can start plugging in some of the specifics about what cloud it should run in, or what size machine instance to use, whatever it may be. But the key is here that as a developer or a author of the application, you don't need to know those specifics. And last part here is the scheduler. So when you have a control plane that is spanning across all these different environments, you then can start making some intelligent decisions about where these workloads should run and where the resources should be scheduled or placed as well. So you can start optimizing for cost or availability, or maybe one of the cloud providers has some interesting innovation or feature set that you want to take advantage of, or best performance, or all these different things you can start. You can use to inform the placement of where these resources would go. So similar to the Kubernetes scheduler that decides which node a pod should run on, this workload scheduler in the multi-cloud control plane here can make decision about what cloud or what environments, like on premises, a workload should be scheduled to. It can use some of those familiar concepts, like affinity and taints toleration selectors and all that sort of stuff to start influencing where in your multi-cloud environment an application should run. And since that application is written in a portable way, that environment of the specific place that the application ends up running can be changed dynamically at runtime. So I think that takes us over to a little demo here. And I think a lot of these concepts might start coming together here when I start showing some of this in person here. So what I want to show you here is the experience of what I'm talking about here, bring all this together. So on the left and right side of my screen here, hopefully this is big enough, make it a little bit bigger. We have workloads. So this particular workload that I have here is going to run WordPress, blog content management system that needs to have a couple of resources underneath it in order to allow WordPress to run. One of those is a MySQL database. It needs some persistence in order to store posts and comments and users, et cetera, in that database. So in this workload here, what we're saying here is that we need a MySQL instance. So this is a claim, similar to persistent volume claim. This is a MySQL claim. And we have here what storage class, what resource class will be used to fulfill this MySQL claim. And then inside of the workload, we have that set of resources that it needs, the MySQL database. And we also have, we can influence what cluster it will end up running in, a payload here, which is a deployment that runs a particular, container. And an interesting part here is, this WordPress app, it needs some information about some of the resources that got spun up for it. So that MySQL database, we need some way to be able to inject into this WordPress application the content, where the MySQL database is running, what the credentials are for it, et cetera. So this is probably a concept that's people are familiar with as well. So when the MySQL database is dynamically brought up in response to this WordPress requesting in a general way that it needs MySQL, the controller that spins up that MySQL instance inside of your cloud of choice also saves its credentials and endpoint information into secrets. And so you can then just reference those that credential information in your pod as secret references, and the Kubernetes machinery will, when it's bringing up the pod, will make sure that those credentials and that information is available inside of your pod or inside of your container. So in addition to how we specified a MySQL claim, we also need a Kubernetes cluster, or in this case, since we're going to be running a pod, we want a Kubernetes cluster for this workload to run in as well. And so very similar to what we did with the MySQL claim, we have a Kubernetes cluster claim. And so this is a general abstraction of a Kubernetes cluster. And we say what particular storage class or resource class will be used to fulfill this Kubernetes cluster claim request. And then let's take a look here at what these resource classes look like. So this is our separation of concerns, where the developer has expressed their general request for a Kubernetes cluster and a MySQL database. And the administrator behind the scenes, just like with storage classes, fills in the details of, what does it mean that you want a Kubernetes cluster? What does that mean? Okay, well, I in my environment here, I'm going to use the GKE provisioner that will bring up a GKE cluster for you. And it's going to use this machine type, and it's going to be in this zone. Similar for MySQL. When you say that you want a MySQL instance in a general way, using this resource class, then that's going to use the GCP's Cloud SQL instance provisioner, such that a Cloud SQL instance will be brought up, and it'll use this machine type and this type of storage, et cetera, and that will serve as your MySQL database and your Kubernetes cluster. So we do this for other types of resources as well, like Redis and object storage and a whole number of other ones in the works. But so now that we've kind of taken a look at what this experience looks like of defining a workload, what its resources are in a general way, and then the administrator being able to specify through storage classes or some of the specifics of the environment to how these requests should be fulfilled. Let's take a quick look at it running now. So I started this up at the beginning of the meeting here, so that it would be, or right before the meeting. So, all these like bringing up a GKE cluster and MySQL databases inside of GCP takes minutes at a time. So I started it before the meeting began. But let's take a look here at, what I'm going to say is kubectl, give me all the resource classes. And so what we have here is those two resource classes that we look like, similar to storage classes, where for a cluster and MySQL, and what provisioners should be used to fulfill those requests, what the reclaim policy is, all those sort of things that are familiar to storage classes that we already know. And now we're going to look at what a Kubernetes cluster claim and resource looks like. So right here, what I've done is I've said, give me all the Kubernetes clusters, which is the same thing as a claim, a PPC. And so we see here that we have one claim for a Kubernetes cluster that has been bound using this this class, this resource class, to a particular cluster, a cluster by this name. And then I say, okay, give me the specific GKE clusters. And that, just like a persistent volume, has been bound as well to the general Kubernetes cluster instance. So we have an abstract, and a concrete Kubernetes cluster, GKE cluster, that are bound together through dynamic provisioning. And one of the last things to look at here is similar to what we just saw for Kubernetes clusters. The same thing happens for MySQL, where we have a general MySQL claim that has been bound to a specific Cloud SQL inside a GCP database instance. So those two are bound together, just like PBCs and PVs. And then let's finally look at the workload. So the workload itself. Now let me make some room here. So the workload itself, we can see that it's in the running state. We see that the scheduler has picked this particular GKE cluster for it to run on. And we can also see that it's got an IP address that we can access this workload on. So if we click that, then we're taken to that WordPress application that was dynamically provisioned along with all of its resources inside of GCP, because of the particular resource classes that the administrator created that specify all the environment details. All right, so that is the demo there. And then, just a couple links here about, where you can find us on GitHub and Slack and Twitter and all that jazz. Since it is a community-driven project, we are open to discussions and new folks coming in at any time. So that's all that I needed or wanted to share here, and I'd be happy. We have some other folks on the Crossplane team here as well. Nick Cope and Bassam Tabar are here as well. So if anybody has any questions, we can get into that, or we can move ahead along. But thank you very much.
Thank you for showing this off. This was really nice to see.
So I had a question. So for instance, a resource like a database, or even resources that are Kubernetes clusters, there's a difference in feature sets across clouds. So typically, when I've seen people take this approach, there's some trade-off between allowing for deep, specific customization for features that are offered by an individual cloud provider, and kind of choosing the lowest common denominator that's implemented across the board. How did you come to a balance between those two kind of extremes?
Yeah, so I think the first way to look at that is that the resources that we're starting to abstract here are ones that are open source projects that have kind of standard protocols. MySQL, Postgres, Kubernetes, the object storage in the form of S3. All the cloud providers have Redis implementations as well for caching. But yeah, you do get into more interesting situations where a particular cloud provider might have a particular feature that you really, really need. In that case, it's a common situation where when you try to do a portable abstraction across a lot of different specific implementations, that to make it completely portable across those, you end up with the set of common functionality there. And if you have a particular, like a very specific feature set that you really need to be taking advantage of that isn't available in the other cloud providers, then this particular completely portable definition of those isn't going to take care of surfacing that specific feature that you may have a dependency on. I was listening to something from Tim Hawken describing the same sort of situation for, I think it was either ingress controllers or for load balancers, and they how they ended up with lowest common denominator, and then specific features were put into annotations, and that wasn't a very scalable model as well. So I think that there's some work to do to how best to capture those specific very provider implementation specific features in either a portable way or in a way that they can be used. Bassam, do you have more to add to that?
Yeah, just one other thought here is that we do, with a separation of concern, we have what the developer or application owner sees. We separate between that and what the infrastructure owner sees. And typically, you can be as specific as you want on resource classes and from the infrastructure owner perspective. The common surface area that we try to capture is from a developer and application owner perspective. The two come together.
Okay.
So, right, and so what you'll find is if you're using something like Redis or MySQL or others, the biggest variance between the cloud providers is around hosting and features that are available in terms of hosting and scaling and compliance and security. From a developer perspective, the surface area seems to be more common, especially from how an application consumes a resource. So we're taking advantage of that property.
So for the resource classes, those are deeply configurable to take advantage of specific features that are offered in an individual cloud. And then when you create a claim for the resource, you attach to that provisioned resource.
Exactly right. So you can be as specific and as cloud provider specific as you want on the resource class. But on the claim side, if you will, it's more generic application owner kind of view on the resource.
Cool. Okay. Let me check and see if there's any questions in chat. See anything popping up there. Okay. So we've got another 20 minutes left. Does anyone have any other discussion topics they'd like to bring up? Okay. Would people like 20 minutes back?
So, quick question. This is Mayank. What's the next step on the Max? Can you guys hear me?
Yeah, I'm gonna try to go. This is for the stateful set. Max unavailable?
Yes, and there was one more, like I have seen a lot of issues related to the broken state of stateful set when image is unknown or things like that. So in the initial state, it cannot be updated. I've seen a lot of people commenting on those issues. So I don't know.
For what?
That at some point.
I didn't hear what you said.
Oh, I was saying that I saw a lot of discussion on the issue where stateful set is broken when an image, initially it's deployed with an unknown image or some other configuration, and then it cannot be updated without manual intervention. So there was a lot of discussion going on that issue. And yeah, and the other thing I wanted to ask was, what was my next step on Max unavailable?
I'm gonna go see if we can't just get it approved in merge and try to chase down somebody who has merge approval on the enhancements, and then we can work on updating from there to get it to implementable.
Sounds good. So should I continue? So I was going to make another update to the PR to like.
Yeah, you can continue. You can continue updating the PR until you see the approval get hit.
Sorry, I know it's not.
You can continue until it gets merged. You can continue updating in place.
Got it. Okay. Thanks.
Anybody else? Okay. In that case, thanks for the great demo, everybody from Crossplane, and thanks for the discussion. And we'll see you guys next week.
Thanks for having us this morning, everybody. Take care.